Alright, welcome back. So hopefully this should be the last part in this zip file download. So what we're going to do now is we're going to create the actual meta file that we want. So first off, we want to include the timestamp in here, right? So let's cut this, and instead we're going to actually put the timestamp into a variable so that we can reuse it. And actually we don't need this done in the with statement. We can just have this done up here. Okay, timestamp equals to that. Okay, so now to actually make the metadata file, let's start metadata, and then in Python we're going to create a multi-line string, and you can do that by just starting the string with a triple equal sign. You see it auto-completes there, so basically anything inside here is treated as one long string with the formatting preserved in it. So what we're going to say is generated at, so this is going to be the timestamp that we want. Whoops, you can tell that by how it's blue that I forgot the F string. So now you can see it's a different color. So we also want the x-axis. Oops. The y-axis. And then what other data can we get in here that'd be useful? Let's see what we have. The trend line. That'd be kind of useful for the user to be able to see that, right? Actually, I wonder if we can do the display for the trend line. Yeah, okay. See how we have the trend line dictionary down here. So what we can do up here is we can say trendline options dot get trend line. Okay, and that should get the actual value from that dictionary, which is the display value that we want. Next up, let's spit out the actual number of records that are returned from that. So we'll get that by just getting the length of the data frame. Okay, then yeah, let's do the actual columns that we're going to get in here. So we can use a join statement for that. So that is going to work on an iterable, in this case a list. So we just put any string that we want to separate the actual items. Then we just say dot join, and then in order to reference this list, what we want is we want the filter df.columns, because that returns a list, right? And then what we do, whoops, is the same thing, just down here. Just want to make sure I get the indents the same. So zip file dot write. Is that write string or? write a file to an archive. Either string or... Okay, so it looks like it's right string. And so we'll write txt, and then this will just be the metadata string that we have. Okay, and then we'll save that. Okay, beautiful, awesome. Oh, and hey, yeah, the trendline thing worked out. I wasn't even planning on doing that, but live coding right there. Okay, so before actually writing the image file in the zip, you need to, when I was trying to run this, I ran into an issue and it yelled at me for not having the Kaleido package installed. So this is maintained by the Plotly team. You can see here I have it pulled up and it's under the Plotly organization here on GitHub. And this package is used for generating these static images in Plotly Python, which is what we're using for our Streamlit. So we need that, and then along with that, you also need, it needs Chrome to be installed, which I know a lot of you have on your computers anyway. One caveat that I found while running this is I'm running my projects on WSL, which is running on top of Windows. So I was like, Chrome. It was saying that I didn't have Chrome, and I was looking at it. I was like, well, I have Chrome right here. So I actually need to install that on WSL, which I'll link the I'll include the actual commands to do that, the apt-get commands to install that in the description. But once you do have Chrome installed, it's pretty much as easy as just pip or pipenv in our case. Install Kaleido. Okay, now it's installed. You can see it in the pip file here. Alright, so we're good to go. Alright, so now for the actual code itself, what we're going to want to do is, first off, we have this generating a figure. We're also going to need this figure in the download now. So we'll say fig equals, and then down here we'll just put the figure. And then this isn't necessarily accurate anymore. We'll just call that download data instead of download CSV. And then we want to pass in the figure, say fig equals fig. That's what we'll name the command, name the parameter. So this we have to rename to download data, and then we want a fig here. Okay. Now where we want this in the code is we want this right before the zip file, because it doesn't need to all be done within this with statement. So we will say, first of all, we'll make a comment. We'll just say image, just to remind ourselves. Then, so like the zip file, we wanted to make a buffer for that. We'll also make an image buffer. So we'll say image buffer equals IO. Yeah, we can just use bytes IO again to take in a streaming data. And then we have access to the figure now, so we'll just say figure.writeImage. And then what is it going to write? It's going to write the image buffer that we passed. And we're going to format this as a PNG. You can format it as a JPEG if you want. Doesn't really matter all that much. And then we just in the zip file down here, we just write the actual image itself. So we say zip file dot write str, and then just say we'll just say scatter dot png for the actual label, and then the data will just be similar to so we're using zip buffer.get value down here. We'll just do that same thing with the image buffer up here. We'll say get value, and then save that. And then, alright, so download, and we've got our zip file, and let's see, it's a little small, I would say, so we can also, this has a width and a height attribute on it as well. So we could say like width equals 1000, height equals 800. That should bump it up a little bit. So now redo that. Okay, and there you go. That's bumped up a little bit. So you can obviously play around with that as you want, but alright, that should be it. So thank you guys for watching.